Hello and welcome to this session on Visum's ABM. I'm Martin, your host for what is now the fifth webinar. This time we will discuss some interesting scenarios and how to implement them. Then I will show you different ways to analyze ABM results in Visum.
The first scenario is a temporary road closure. We will implement this scenario and analyze how it affects mode, destination, and time of day choice. To start with, we need to do a little preparation in the model. Since we want to analyze the effect on the time choice, we first need to activate this choice level. To do this, we navigate to the procedure parameters, the Basic tab, and check the corresponding box. As you can see, there are two options: calculating time choice or calculating individual time preferences. We choose the second option. This enables a modeling approach, also known as incremental modeling. You may have heard of incremental modeling in the context of the UK Transport Analysis Guidance called WebTech, or simply in one of the previous webinars in this series. Before we continue with our scenario, I will briefly go back to incremental modeling. Maybe you remember this slide. I have shown it many times. When creating this synthetic population, the persons not only carry their attributes with them, but also their daily schedule, including the start times of the activities. This is really cool, because then you don't have to calibrate the start time model, which can be really time consuming, and you work with super realistic start times. On the basis of these reported start times, we prepare the choice model so that it reproduces this choice. We do this by setting individual preferences so that in the base case, the reported start time wins. Of course, such a model is not set in stone, as we will see shortly. If the systematic utility changes, the decision can also change. There is a second new entry, the opening hours. Here you define for each activity type when this activity can take place. When selecting the start time, only the start times for the main activity are taken into account, in which all activities of the tour take place entirely during their opening times. Here is another slide to illustrate this. The start time model focuses on the main activity within a tour and only decides on the start time for this. The start times for all other activities are automatically derived from this. To avoid unrealistic execution times, Visum's ABM uses the concept of opening hours. A tour may only be shifted in a way that all activities of that tour can take place during the corresponding opening hours. This helps to prevent midnight shopping, for example. We now run the demand model to create the individual time preferences. This means that all time choices remain unchanged and only mode and destination are chosen. Now let's look at the results. You can see the distribution of activities throughout the day. We limit the display to shopping trips only. We can also do a little debugging. If you click in this area, it will show all the activities that are being carried out at that time. When we look at this, we might want to analyze a specific item. Just click on it and you will see it in the network editor and in the list. Okay, let's go on and take a look at the network editor. The blue triangles are shopping locations. There's one shopping location outside of town, this one. It is an outlet store, very large, but far away. In our scenario, we will close a road during PM so that no private car can get to the outlet store. This road is here. To simplify the example, we will simply increase the travel time on this small piece to infinity, and only for PM. Then we run the demand model again. Before doing so, we need to make a slight change to the procedure settings. Check the box Calculate Time Choice. This is because we have already calculated the individual time preferences and prepared the model for the incremental calculation. Now we will run the model in a normal mode, also known as the absolute model, but with incremental individual preferences. After running the scenario, some decisions have changed. You can see them here in the list of activity executions. This list shows all activity executions in the outlet store that were approached during the PM time period by car in the base case. When we filter them by start time, we see how many start times have not changed. We can filter further by mode, resulting in trips that have not changed mode. But all of them have changed destination. Of course, it is no longer possible to drive to the outlet store by car. When you click on the activity executions, they are highlighted as red circles in the editor. I've also prepared a nice slide comparing two activity profiles. You see the activity executions in the outlet store of people who drove there by car. The light green profile shows the scenario result. The red is the base scenario. Where the two colors overlap, the result is shown in olive green or brown. The blue strip indicates period when the road is closed. The red area represents the lower activity during the PM and also later. Some activities have shifted to other periods, highlighted in light green. Now we arrive at a different type of analysis, a flow bundle. A flow bundle that connects assignment paths with trips that use those paths. To do this, we first have to convert the trips into path sequences. A path sequence is more or less the same as a tour, but with a connection to assignment paths. Visum has a simple procedure for this conversion. You just have to execute it. Here is the corresponding list of path sequences. Then we define a flow bundle. For example, this road. We now want to find out who used this road and why. To do this, we open a list of path sequences. And add this quite special attribute. Volume Flow Bundle. I filter the list a little, and you see those tours that use the Flow Bundle road. If we now summarize the list to a certain person characteristic, for example occupation status, we get the distribution of road users by occupation status. In the same way, we can analyze a similar list, the list of path sequence items. Such a list can be summarized by trip purpose, and we get the distribution of travelers by trip purpose. It is also possible to convert the trips into demand matrices and then run an assignment. There is a simple procedure for this. Calculate demand matrices from trips. You just have to define which matrices are to be filled and which trips are to be evaluated. Here you can see the public transport demand matrices, one matrix for each time period. After the procedure has been calculated, the matrices are filled. They can now be assigned in the usual way and then the assignment results analyzed. Incidentally, matrices can also be generated at the stop area level and then assigned. Last but not least, another way to analyze, or better visualize the data as moving beans. That means animated objects that move through the network. To do this, you would upload the model data to our PTV hub and use the Dashboards app. This is what it would look like. It is perhaps not so much a tool for analysis as for demonstrating to end customers how an ABM works.
That's all for today. I hope you liked today's session. Join me next week on Tuesday to finish the webinar series with a discussion about the data requirements and calibration process.